Hey there, and welcome to the Confident Chemistry Teacher Podcast. I'm Kim, your go-to chemistry coach for engaging teaching strategies and simple solutions to the everyday challenges chemistry teachers face. Let's get this reaction started. Hey chemistry peeps, this week I'm going to be giving you one of the Inside the Unit podcasts where I'm going to talk about my favorite activities for this unit. So I like this unit. I have kind of gone back and forth about where I place this unit in the year. Sometimes I'll put it second, sometimes I'll put it third. This year I'm at a new school and students are seeming like they don't have as much experience doing hands-on labs and measurements. So I think I'm going to do it third this year and actually do scientific math second. So I think that's just going to help build up some of their understanding and their knowledge before they jump into some of the activities. Now, this matter and change unit I think is really important to do at the beginning of the year, whether you do it second, third, fourth, whatever, because it builds vocabulary. So students are going to learn terms that we're going to talk about and need to use correctly for the rest of the year. Again, this one, just like our first day of school activity with the modeling, helps us classify things, and I think that's a huge idea or skill to have in chemistry. So we're going to be classifying things to help build the vocabulary terms, help to understand the difference between physical and chemical properties and changes. We're still early in the school year, so we're still setting expectations where students can gain that confidence. They're also gaining lab station expectations. So none of these labs are too crazy, although the one that I'm going to talk about in this unit gets more complicated. And so they finally feel like they're doing some real chemistry in here. So it's helping build that lab confidence as well as getting to know those expectations. Now, there are some standards that go along with this with the national science standards. So I'm just going to read them off real quick. So high school standard PS1-2, construct and revise explanations for chemical reactions using atomic and molecular structures. HSPS 1-3, plan and conduct investigations to gather evidence of physical and chemical properties of substances. And then there's some science and engineering practices like developing and using models, analyzing and interpreting data, and constructing explanations. I love that one. And then the cross-cutting concepts of patterns and cause and effect. So I feel like the kids see those on some of my state standardized tests and then on the ACT. Now, some of the stuff that when I first started teaching, I really noticed the kids struggled with. I used to just lecture and have the kids write down the vocabulary terms. And hey, shockingly, they didn't know how to use them after that single lecture. So now in this unit, I've built in a lot of different practice activities so that they're really using these terms. They're developing their own concepts. Just repeating it in different ways really helps cement that knowledge for them. Okay, so the first thing that I use that I kind of stole from a book when I was first starting teaching chemistry are the idea of T-charts. I wish this was a video in this one small instance and that I could show you what it is. So just imagine you've got a T and you've got a set of terms under the left side of the T and then a set of terms under the right side of the T. Generally, all the things on the left side are all very similar to each other, and the things on the right side are not very similar to each other, or they're very different to the things. So, for example, we might have things like if the idea is for students to understand the difference between a mixture and a compound, one side of the T would have things like apple pie, gasoline, chicken noodle soup, paint colors. So all of those obviously would be mixtures. And then on the right side would be things like carbon dioxide, carbon, the formula for sugar. So the idea, of course, you guys being chemistry teachers, is that mixtures have variable compositions, while substances, or pure substances, some people like to say, have definite compositions. So the idea is the kids are supposed to look at the difference between each side, look at how they're similar, and then categorize how they would determine each side of that T-chart It's kind of building on the skill that we did that very first day where we did the scientific modeling activity where they had to classify planets or car companies, something along those lines. So the idea is here is that the kids are really in their brain and they're working with their partners in their small groups. They're coming up with their own definitions. And so sometimes the kids will give me a word to put on the left side of the T chart or the right side of the T chart, and it's not exactly right, but at least they've come up with their own definition. So I do this in PowerPoint, which I'm going to share with you guys. I've been trying to think what is like one useful thing that I can share during each episode, and I think that this is definitely it. And then I have the kids draw these 6 small T charts in their notebooks. And so after we have figured out what we want to call each side of the T chart, I'll then write the actual definition that I want them to write in their notebooks as well. So even though this lesson really does take about 30 minutes with these T charts, they're like super solidly coming up with like the most important vocabulary terms for what I want them to learn in this unit. And if I'm thinking off the top of my head, the example I just used was mixture and substance. So that's definitely one. Element and compound, knowing the difference between those, physical and chemical changes, qualitative and quantitative terms. And I don't know why I can't think of the last couple, but there's a couple more that are in the slide deck that you can access. So remember, just go to the show notes and you can see those. So the idea here is that the students are really like classifying and coming up with their own definitions here, and I love it. After we do this T-chart activity, I kind of mentioned it takes about 30 minutes. We totally do a worksheet either that day or the beginning of the next class to kind of cement that knowledge. And then when we do our study guide, they'll see some of these terms again to bring that back. And then, of course, my bad, we'll actually do a lab where we use these terms later as well. Now, the next big thing is to identify the difference between physical, chemicals, properties, and changes. So I really just kind of do like a simple like definition for them. Then I have the kids do a card sort. And I am really loving laminating things. I know it's so bad for the environment, but I love like when they don't come up beat up. And plus, the kids' hands seem so dirty these days. So I really like them coming back laminated so I can just wipe them off and they seem brand new when they're done. This physical and chemical properties and changes card sort, the way it works is they just have like a definition, like it says physical property, one card, another card says physical change, and then they have about 15 cards underneath where they can go ahead then where the cards have examples of those properties or those changes, and they just have to correctly sort them. Again, it's a simple in their seat yet hands-on activity that the students are practicing this. Then, while this isn't super, chemistry, you're going to see as you listen to these podcasts, I like to throw some fun activities in along the way. So one of the activities I like to do is to make peanut brittle in my class. So before you're like, oh my gosh, peanut brittle, peanuts, allergies, I really call it goody brittle. I say peanut brittle at first, and then I tell the students it's goody brittle, right? Because I obviously don't want to harm any of the students in my class, but most people can imagine what peanut brittle looks like. And so then the goodies that we use might be like Oreos, graham crackers, gummy bears, or like any other like thing that another kid in the class wouldn't be allergic to. And it actually comes out really pretty good, and the kids really enjoy that. And I think I forgot to say, we do this because not only do we get a tasty treat, and I'm all about making food, we review the physical and chemical properties and changes in real life. I feel happy that these kids could now make peanut brittle during the holidays. And just as kind of a side note for this, they're going to need like a small pot, a wooden spoon. And then over the years, I've pretty much accumulated enough of those to like supply. Although now that I've moved schools, now that I think about it, I'm going to have to maybe restart my collection. But I usually have a big box. I tell the kids to bring in their own pots. Most of them do, but of course you've got a few kids who don't bring them in. So I have this box where I can just hand them out. And then the kids are also bringing in like measured out 1 cup of sugar. They're bringing their goodies in. So really the only thing that I usually provide for this, besides some backup pans and wooden spoons, is some extra sugar in case kids don't remember it, and then the baking soda. They also need baking soda for this lab. So I do provide those. And usually if kids forget goodies, they can run down to the vending machines or kids can share in class. So far we talked about the T-charts. I really like that for building vocab. We do a little worksheet. Okay, I think kids need worksheets. Okay, I was going to feel bad about saying worksheets, but I'm like, yo, people, let's be real. We do worksheets. Then we do the physical and chemical property and change card sort. We do this fun peanut brittle lab. Again, tasty treat, learning to identify the difference between physical and chemical changes in real life. The other next thing that I like to do that I'm really excited about doing is this 8 lab station matter and change activity. Did I say that in a right order? I have 8 stations that kids rotate through where they practice different skills in each station. Now, I don't know why this is. I feel like before COVID, kids could get through all of these 8 stations in a day. But after COVID, I now definitely take 2 days to finish up these 8 stations in my classroom. I'm going to be talking more about this lab in a future unit, but it's like some simple things that they'll do, like they'll take some Alka-Seltzer and they'll make some measurements. They'll burn some magnesium oxide. They're just finally practicing or doing some chemistry skills while they're practicing identifying physical and chemical changes and using those vocabulary terms. So now one thing I definitely still struggle with in this unit, which I'd love to hear your guys' feedback on, are separatory techniques. I do a pretty cool little chromatography lab. It is Who Wrote the Hall Pass. So we do a pretty cool chromatography lab. And in that 8 station lab that I mentioned a minute ago, there are some separatory activities there, but maybe I just don't feel like I have like a great PowerPoint or a great worksheet. I just feel like I'm not doing it justice. So if you guys have you're like, this is an amazing way to teach the separatory skills or separatory techniques, I would love to hear them. So I hope you found those ideas for matter and change to be helpful. And like I said, I am going to put the T-charts in the show notes there. And then in a future episode, I'm going to talk about those 8 lab stations that I do. Now, some of you guys might not be to matter and change. So remember, if you're still looking for some scientific measurement activities, I do have that Google Slides presentation on accuracy, precision, estimated digits, and significant figures on TPT. It includes Google Slides presentation. It has 2 quiz trade card activities. It has fill in the blank notes. It has a cheat sheet for students, and then links to 3 videos that I actually use with my own students. And then if you're looking for a free resource besides the T-charts that I included, don't forget to check out my math starter kit. In that math starter kit, it has a significant figures poster. It has the Google Slides presentation on ocean currents. It also has a quiz trade activity in that, and it has a few other things that are going to help make your math unit more exciting. As always, guys, keep inspiring, keep experimenting, and keep making your classrooms more awesome. Until next time.